Hello everyone, this is mathematics lesson for grade 8. This program is organized by Addis Ababa City Administration Education Bureau in collaboration with Addis Media Network. I'm teacher Mamu. Today we will have a discussion which is a continuation of the previous lesson. Okay, as you all know, in our previous lesson we have started our discussion on the concept of probability, and we have seen around 6 definitions, and we also observed some examples that helps us to understand the 6 definitions. Okay, just to shortly remind you what we have seen before, the first definition that we have seen is about experiment. Do you remember the definition of experiment? Okay, an activity involving a chance in which results are observed is called an experiment. And the second definition was about sample space. A sample space is defined as the collection of all possible outcomes in an experiment. Okay, so the collections of all possible outcomes in an experiment is called a sample space. The third definition was about an event. Well, do you remember what an event is? An event is defined as the subset of a sample space. Okay, that is the definition of an event. And the fourth definition that we have seen in our previous lesson was about probability of 2 or more events. Okay, so 2 or more events are said to be equally likely if they have equal chance in the experiment. Okay, and the fifth definition was about certain events. Okay, an event which is sure to occur is called certain event. Okay, if you are 100% sure that the event occurs, then you can say that event is certain event. In contrary, an event which cannot occur at any performance in the experiment is called impossible events. Okay, so these are the 6 definitions that we have seen in our previous lesson. Today, we will have one more definitions and properties of probability. Then we will see how we can calculate probability of a simple events. Okay, so the 7th definition is about probability of an event. Okay. So probability of an event is probability of an event is the measure of a chance in which the event occurs in an experiment. Okay, this is the 7th definition that we have in Unit 8. So generally, probability of any event is a measure of a chance in which the event will occur as a result of the experiment. Okay, through the process of the experiment. And the next thing that we have is properties of probability. Okay, so we have properties of probability. Well, to understand the property of probability, let's have a certain sample space. Let S be a sample space, and E be an event. Okay, assume we have S and E, which is the sample space and the event, we will have the following 5 properties. The first property of probability is the probability of any event is between 0 and 1. Okay, just to clarify this P of E is a notation that we use to represent probability of an event. Okay, so for any probability, for any experiment, the probability of an event is always between 0 and 1. Okay, so this is the first property. The second property is P of E1 is greater than P of E2. Okay, if this happens, if probability of event E1 is greater than probability of event E2, then we can say that E1 is more likely to occur than E2. If this happens, then E1 E1 is more likely to occur than E2. In other words, if P of E1 is greater than P of E2, or if probability of E1 is greater than probability of E2, E2 is less likely to occur than E1, or E1 is more likely to occur than E2. Okay, so this is the literal meaning of this condition. The third one is if P of, or probability of E1 and probability of E2 are the same. Okay, if probability of event E1 and event E2 are the same, then we can say that E1 and E2 are equally likely to occur. Okay, then E1 and E2, that means event 1 and event E2, events 2 are equally likely. Okay, so for example, you can take an experiment like throwing a die. In throwing a die, obtaining an odd number and obtaining an even number are equally likely, because both events have equal number of chances. Okay, for odd you have 1, 3, 5. For even you have 2, 4, 6. Since the cardinal number of these two events are the same, you can say that the probability of those two events are equally likely, or these two events are equally likely to occur in the experiment because their probabilities are the same. We will see how we can calculate the probability of such an event, but for the time being, whenever you see the probability of E1 and the probability of E2 are the same, we mean to say that those two events are equally likely to occur. Okay, this is the third property. The fourth property is probability of, if probability of a certain event is 1. You may have a probability whose value is 1. Then this event is called certain event. If you remember in our previous lesson, we have seen the definition of certain event. Okay, so whenever you see probability of a certain event is 1, then you can conclude that that event is a certain event. Then E is certain event. Certain event. The last one is if probability of an event is 0. If the probability of an event is 0, then we can say that E1 is impossible event. Then E is impossible event. As you remember, we have defined what an impossible event is. Shortly, an event which cannot occur at any performance in the experiment is called impossible event. So the probability of such event is 0. So you need to remember all these 5 properties whenever you calculate the probabilities. Look, in your calculation, if you get a probability whose value is bigger than 1, that activity or that experiment is wrong or biased. We cannot have a probability whose value is bigger than 1. Okay, so next we will see how we can calculate the probability of a simple events. So let's proceed to the examples. A box contains 4 black balls, 6 red balls, and 5 white balls. Okay, so we have a certain box containing 3 different colored balls, 4 black balls, 6 red balls, and 5 white balls. Randomly select one ball. Randomly select one ball. What is the probability? What is the probability of getting? What is the probability of getting the first one, black ball? The second one is red ball. The third question is white ball. The fourth one is green ball. Well, so what is given here, there is a box containing 3 different colored balls, 4 black balls, 6 red balls, and 5 white balls. And the activity here is we are randomly taking a ball from a box. In this situation, what is the probability of getting black ball, red ball? Each of these are separate questions, okay? So you need to answer the probability of black ball first, then red, white, then green. Okay, so to calculate this probability, I will give you the formula that you need to apply to calculate the probability of simple events. Okay, so the probability of an event is the ratio of the cardinal number of the favorable event over the cardinal number of the sample space. Okay, so this is the formula that we use to calculate the probability of any event. Okay, so from this formula, always we need to understand what an event is mean, what a sample space is mean, depending on the scenario that we have, right? So don't forget this formula. We will apply this formula to calculate the probability of this activity. Now, let's answer the first part. How many black balls do we have here in this box? Clearly, there are 4 black balls. Therefore, the cardinal number of events is 4. Okay? The sample space is the total number of balls in the box. Because by definition, a sample space is all the possible outcomes, right? So n of s is 15, because totally we do have 4 plus 6 plus 5. The sum of these 3 different colored balls is 15. Now, let's answer the A part, okay? So in A part, we are asked to calculate the probability of getting black ball. I'm using this notation to say probability of black balls, okay? You can use different notation, it doesn't matter, but to differentiate the probability of these different colors, I use P of B to shortly mean that probability of black ball. So the probability of obtaining black ball is equal to the number of favorable outcomes. How many black balls do we have? 4. So it becomes 4 over the sample space, the number of balls in the box. That is the sample space. So it's 15, okay? If you calculate this number is clearly between 0 and 1. It cannot be bigger than 1, or it cannot be less than 1, I mean less than 0. So this is the answer for A part. When we go to the B part, we are also asked to calculate the probability of obtaining red ball in this random picking. So the number, okay, the number of favorable outcomes in the second case is N of E, which is the number of red balls is 6. So N of E will take 6. And N of S in all cases is 15. Okay, the number of sample space is 15. So the answer for B part, is about probability of obtaining red ball. So probability of red ball is equal to 6 over 15. If you want, you can simplify this by 3. It becomes 2. By 3, it's 5. Okay, it becomes 2 over 5. 2 over 5 is the least simplified form. Don't worry about the simplification. You can put this thing as it is, 6 over 15, or the simplified form, 2 over 5. So this is the probability of obtaining red ball in this experiment. The third case, we are also asked to calculate the probability of getting white balls, okay? So the favorable event here will be the number of white balls. So we do have 5 white balls. So you can substitute 5 here, and N of S is the same for all these cases. So the probability of, the answer for C is the probability of getting white ball, which is equals to the number of white balls over the total number of balls in the box, which is 15. So 5 over 15, or in the least simplified form, you can make it 1 over 3. Okay, by 5 it's 1, by 5 it's 3. So this one or this one is the probability of getting white ball. The last one is the probability of green ball. Well, in this box, we don't have green ball. So the number of favorable outcomes in this case is 0. So in place of N of E, you can substitute 0. So the probability of getting green ball is 0 over 15, which is 0. And you can say this is impossible event. Okay, in the properties that we have seen earlier, an event whose probability value is 0 is called impossible event. Actually, we cannot pick any green ball from this box because the box contains only these 3 colored balls, black, red, white, so we don't have green. So there is no way to pick green ball. So our probability of picking green ball will be 0, okay? So it do not contradict with the property of probability. So this is the first example on probability of simple events. Let's see the next example. So consider tossing a coin. Tossing a coin once. Okay, in our previous discussion, we have seen in tossing a coin, we have seen what the experiment is, what the sample space looks like, and what the events are. Here, we are going to calculate a certain probability in this activity. So tossing a coin once, what is the probability of, what is the probability of getting A, head, B, tail? Well, so the experiment in this case is tossing a coin. In tossing a coin, we have, in tossing a coin once, we have only two options. Okay, the collection of those two options will be our sample space. Okay, as we did in the previous example, the first thing that you need to do is you need to list out the sample space and the favorable outcome to calculate the probability of a certain event. So to answer this one, first we need to put the sample space. Okay, can you guess what the sample space contains in this experiment? Okay, suppose you a coin, the output can be head or tail. There is no other option because we are throwing we are tossing a coin once. So the sample space will contain the outcome head and tail. Or shortly we use this notation capital H and capital T to mean head and tail. No more other option. So this set is a sample space. Now we go to the questions. We are asked to calculate the probability of getting head. So for first case, the event will be getting head. Okay? So how many elements do we have in this set? We have one. Okay? So we apply the formula that we used in the previous example. The probability of an event is equal to the number of favorable conditions over the number of the elements of the sample space. Okay? You only need to remember this formula, nothing more. So if the event for A part is this one, the number of elements in the set is only one, and the number of the sample space, okay, the sample space contains only two, so the cardinal number of the sample space is 2. So the probability of getting head in this experiment is equal to the probability of getting head in this experiment is equal to the cardinal number of the favorable condition over the number of sample space. So this is 1/2, or 0.5, or there is 50% of chance to occur head, right? So there are different ways to answer this thing. You can roughly write 1/2 is the probability of getting head, or you can make it 0.5, or you can express your answer in terms of percentage. Okay, so knowing the different ways of answering probability is very, very important, because you will be asked to express your answer in different forms. Okay, this can be or 0.5 or 50%. Okay, there is 50% the head to occur. Okay, similarly, when we go to the B part, in B, the event is, or the favorable condition is tail. So you have one tail here. Don't forget, you only pick the event from the sample space. So how many tails do we have? One tail. So you can write it a set containing tail. So the cardinal number or the number of elements of set E is 1. So this implies, okay, this implies the cardinal number of set E is 1. Now, the probability of this event, the probability of obtaining tail is equal to the cardinal number of E over the cardinal number of the sample space. This is 1 over 2. Or you can make it 0.5, or you can say 50%. Okay, the tail have 50% to occur. Very simple. Now, I will change this example by tossing a coin twice, and we will see what will happen. The third example is about tossing a coin. Okay, the previous was about tossing a coin once. Now here we are going to do an activity tossing a coin twice. It can be one after the other, or it can be tossed by two people, whatever the case. But here there is tossing a coin twice. In this case, find the probability of getting number 1, bull's head, B, bull's tail, C, at least one head, at most one head. Okay, so let's see this experiment. Here, you need to properly understand the experiment first so that you can be able to, list out the sample space. Here, the experiment is tossing a coin twice. Look, you can do this activity in your home. Toss a coin, you'll have such outcomes. Okay, our sample space will have bull's tail. Okay, there is a possibility of getting bull's tails in the experiment. The first can be tail, the second can also be tail. This is one of the possibilities that will be happening in tossing a coin twice. Okay, can you just tell me the other possibilities in this experiment? Okay, you can get bull's tail, that is one option. The other option, the first can be tail, the second can be head. Can you add the third possibility? Well, the third possibility can be, the first can be head, the next can be tail. This is the third possibility. And the last possibility in this experiment can be obtaining bull's head. Okay, so these are the collection of all possible outcomes. We don't have any other possibilities except these 4 cases, right? So this is our first step to calculate the probability of any event. Then the next step will be listing out the favorable condition depending on the question. So in the first case, we are asked to calculate the probability of obtaining bull's head. So where is bull's head? Okay, here we have a single case. That means HH. So the favorable condition or the favorable event in the first case is an event of HH. And this event contains a single element. So the cardinal number of this event is 1. Okay? Here, the sample space contains 4 different possibilities. So the cardinal number of the sample space will be taken as 4. Okay? So now the probability of getting Bose head will be the ratio of this number over this number, okay? So the probability P of X, okay, just to make it short, you can say P of X. Here, P of X refers to the probability of getting HH, or you can make it P of HH. Okay, so in this case, the probability of getting Bose head will be 1 over 4. 1 over 4. Okay. Similarly, we go to the probability of getting Bose tail. Okay. Again, we observe the elements of the sample space. How many double tail do we have in this sample space? We have only TT. So the events of getting Bose tail is only this situation. So in B, the events are, the event contains a single case TT. And this cardinal number of E becomes 1. Okay, the cardinal number of the set A is 1. Therefore, the probability of obtaining Bose tail is N of E over S of E. Okay, don't forget the formula. Use N of E over S of E. The cardinal number of S, which is 1 over 4. By the way, you can change this 1 over 4 into 0.25 or 25%, right? So there will be 25% of getting, okay, the chance will be 25% of getting head, the same thing for tail. Now, I need you to strictly focus on the statement which are found in C and D. This is very, very important, and it's a kind of question that requires attention. Look, in C case, we are asked to calculate the probability of getting at least one head. When we say at least one head, the favorable condition is including one head and more. Okay, so you cannot take TT. Okay, TT cannot be included in this event, right? So the probability of getting at least one head contains the event. Okay, here in this case, at least one head. This can be taken. This can be taken. And Bose head can be taken. Okay, you are free to take Bose H. So your event will have a set containing TH, HT, and HH. Okay, so this is the favorable condition. So the probability of getting at least one head will be the number of the cardinal number of E over the here, let me write it. Say P of X is 3 over 4. Why 3? Because we have 3 favorable conditions based on the statement in C. And the last one is at most one head. At most one head refers to you can take maximum one head and you are free to avoid the head. So when we say at most one head, we cannot include this HH in our event because this is 2 head. So maximum you can include 2, and you are free even not to take the head. So the event in this statement will be a set containing TT, TH, HT. Okay, don't forget you have the right to take TT because it says at most one head. So you are free to take even Bose T. So this event will have the situation TT, TH, HT. Okay, so the probability of getting at most one head will be the number of elements here, which is 3. Okay, the probability of such event is 3 over the number of the sample space 4. Yeah. Oh, better. So this is the probability. Okay, so now you can paraphrase these results in different forms. For example, the situation in C and D have the same probability, and you can say these probabilities are equally likely to occur, and the situation in A and B have the same probability. That means the probability of obtaining both head and the probability of obtaining both tails are equally likely because their probabilities are the same. Okay, we have the same probability. So that's how you calculate the probability of simple events. I will add one more example to elaborate how we can calculate the probability of simple events. Example 4, consider throwing a die. Throwing a die. Well, you need to understand the statement first so that you can sense what the experiment is. Here in this example, we are throwing a die. Remember, a die is a cube with each face having different numbers. Okay, so in this case, find the probability of getting 1, an odd number, the second one an even number, the third one is composite number, and lastly, a number different from 2. A number different from 2. Here, the experiment is throwing a die, and this activity, we are asked to find the probability of getting an odd number, an even number, composite, and a number different from 2. So as we did before, our first step is listing out the sample space. Okay, so the sample space in this case, the sample space in this case contains numbers 1 up to 6, because a cube contains 6 faces. Each of the faces contains different numbers. So you can write 1, 2, 3, 4, 5, 6. Okay, this is our sample space. So there are 6 possible outcomes in the experiment. So the cardinal number of the sample space, is 6. Okay, now let's see the events of getting an odd number. Okay, how many odd numbers do we have here in this set? 1, 2, 3. So you can list out the favorable condition in this case, 1, 2, 3. So the cardinal number of this set is n of e is, or the number of elements of set E is 3. Okay, so the probability of an event in A part is 3 over 6. Why 3? Because it contains 3. So 3 over the number of the sample space, the number of elements of the sample space. So 3 over 6 can be simplified. You can write it 1 over 2. Okay, its equivalent form is 1 over 2 or 0.5. Okay, so this is the probability for the event in A. Here, let's see the second event. An event, the probability of getting an even number. So what are the even numbers in this probability set? Okay, so the even numbers are 2, 4, 6. So you have to list the events 2, 4, 6. So how many elements do we have here? 3 elements. So the cardinal number of set E is 3. So the probability for the second statement is, the probability of an event is 3 over 6 or 1 over 2, or make it 0.5 in different ways. So this is the probability for the statement in B. In the third case, we are asked to determine the probability of getting a composite number. So first of all, what is a composite number? Well, a composite number is a number having more than 2 factors, right? So the only number, not the only, there are 2 composite numbers in this set, 4 and 6. As you can check, 4 has 3 factors, 1, 2, 4 itself, 1, 3, 4, 5, 6. So the cardinal number of this set contains, the cardinal number is 5. Therefore, the probability of such event is equal to 5 over 6, okay? Always in the denominator, you need to put the cardinal number of the sample space, okay? So this is all for today. I hope you got something from my presentation. If you have any question regarding what I have presented so far, you can reach me out using my number listed here. Okay, this is my number. You can reach me out.